Welcome to Chapter 7. We're going to talk about exponential growth and decay. So there's a couple little things in this new equation you have going on. A, which is coefficient. We have b, which is the base, and x is the exponent. If a is greater than 0, okay, we always want to have that for exponential, and b is greater than 1, then we're talking about a growth. So the big thing there is b is greater than 1. If a is greater than 0, and b is less than 1 but still positive, then it's decay. It's that simple. In either case, the y-intercept is 0a, which is that first value. Domain is all the real numbers. We're going to have the asymptote at y equals 0, and the range is going to be y is greater than 0. And I circled a already because this is like having 1 times 4, so that means b equals 4. So that means it's a growth. Again, we're going to throw 1 in here, so b equals 1/3, which means it's a decay because it's less than 1. Here we have a equals 2 and b equals 3, which means it's a growth because 3 is greater than. Alright, so what do we have? We're going to throw in 0, and we get 1. Okay, that's going to give us the a value, so 0, 1 works there as well. You should probably see something on the negative side. Negative 1, 1, and 2, I guess. Negative 1 is going to give us 1/4. 1 is going to give us 4. And 2 is going to give us 16. So we'll see that puppy grow really, really fast. So let's get those plotted. Ooh. 1. Negative 1 is going to be 1/4. 1 is going to be 4, and 2 is 16. Alright, so we're going to see these really close to the y-axis and then jump up there. Looks like a growth because it is and should be a growth. So let's see what happens. We flip those around. 1/3, so let's throw in the negative 1, 1, and 2. Let's see what happens. So negative 1 gives us 3. 1 gives us 1/3. 2 gives us 1/9. So we should see the exact opposite of that. So negative 1 is 3. Here's our y-intercept. Here's 1/3 and 1/9. So let's see these points swoop down for a decay. Alright, plug in 0, we get 2. That's that a value, right? A equals 2. If we plug in negative 1, we're going to get a, which was 2, times 1/3, so 2/3. Plug in 1, we're going to get 2 times 3, so we'll get 6. And we'll plug in 2, so 2 times 3 squared, that's 9, 2, 18. So you see that growth, and it's just multiplied by 2, so that would be a vertical stretch, just like we talked about in all the other functions. So 0, 2, negative 1 is 2/3, 1 is 6, and 2 is 18, which would be way up here in my scratch work. So we see that growth go way up from there. So that's how we graph it. We identify growth or decay. So I'm going to label that's my a value, that's my b value. So if b equals 4, that's a growth based on the definition. Again, a, b equals 0.75. Makes it a decay. We're going to put $2,000 into a college savings account for 4 years. The account pays 6% interest annually. And let's see here. We want 6% interest annually. So that is 0.06. Now here's the whole thing. Is interest is talking about adding 2 into a savings account. So what happens all the time is we're going to put 1 in front of that. So if I want to find the actual value, which they didn't ask for here, but since we want to put it into a savings account and make money, this is going to be a growth of 6%. And this is kind of where the conversation happens in class about this, is that we want to have a growth of 6%. So that number has to be greater than 1. So we put 1 in front of it because I want to keep my $2,000 and add on what's after that. So using the distributive property in reverse is we make it 1.06. gives us our growth. Okay, so this makes our y-intercept 2,000 here. I kind of skipped over that last part here. So remember the a value will give you that. So 0, 3 and 0, 11. And we also answered the growth or decay part of all three of those. Suppose you invest $1,000. So that's my a value. Pays 5% interest. B equals 5% interest. So that equals 1.05. You make no additional deposits. How many years will it take? Well, that's going to be the x value to at least $1,500. $1,500 is what we want. We're putting in $1,000 at 1.05 to the x power. So we can do some calculations. Alright, as we divide, now we get to a whole different ball game, and we're going to be guessing and checking. I know if I put in 1, I'm going to get 1.05, which is not the 1.5 yet. So we're going to have to keep going. We're going to find out through making a table, guess and check, keep increasing, that it's going to be, has to be greater than 8 years. Okay, greater than 8 years. We can take a look at the graph in class. Or we can just continue making that table. We want to make sure, we want to find out when it's going to be at least $1,500. Okay, so that's the application. Second type we're looking at is we have a 1 year change here. We're looking at the Iberian links. So we have 150 minus 120. They didn't give us a percent change, so we have to find out what it's changed. So it's 30 over 150, which is 0.2. And that number is going down. Okay, so from year to year, that number is going down. So we have a decay of 20%. And here's where things get tricky. If I want to write the equation, I have 150 is how many cats we started with. I'm going to use 0.8 to the x power because we want to find out how many cats are left. If I put in 20%, that means I'm going to find out how many we have lost. So like we said, if you lost 20%, we kept 80%. Think about that. I just gave you a test back or something like that. And if I wrote 80%, it means you lost 20%. And we're asking about 2014, so already an old question. So that would be 11 years from the 2003, that starting date. So put in 11 years, so 0.8 to the 11th power times 150. We're going to round that off at 12 cats. If we expand that and say, all right, what about 2020? Because that's something that's still in the future here. So now we're going to plug in 17 years, right? 2003 to 2020, that's 17 years. 150 cats, losing them at 20%, we'll be down to 3 cats, which means they will be extinct. Okay, we have to make sure we have the males and females to keep more cats coming. Here we go. Alright, so looking at some homework here, growth and decay, y-intercept, so it goes along with what we talked about. Looking at the interest, remember if you want to find out when it is, we're going to guess and check, or you can use a graphing calculator to tell you when it's going to reach that point. And we want to make sure that we can write that equation so that models exactly what we did here. And then the application, so giving you that equation and asking you some follow-up questions about how many feet, what's going to happen after that, and also another cat question. So I'm going to follow up with those. All right, make sure you have those when you come in.